So if we think back to the types of cells, when we're looking at bone, okay, we have those osteochondral progenitor cells. Because when we're looking at bone, if you remember, one thing that I keep trying to point out, bone is dynamic, meaning it continuously remodels, okay? It's going to grow throughout until you reach your full height. Once you have reached your full height, the bone continues to break down, build back up, okay? So it's dynamic. And in the case that there may be damage, like a bone breaks, do you happen to remember what type of cartilage will be the blueprint, Whitney? The hyaline, okay? So that means that that connective tissue wrapping has to contain the stem cells for both cartilage and bone. Therefore, those osteochondral progenitor cells. Does everybody remember that? Now, before we go into the next part, because bone, first of all, has to form, okay? And then it has to do the repair and the remodeling and the ability to withstand stress, okay? Bone has the ability to be what is called woven. What do you kind of think of when you hear that term? Weaving, okay? And things kind of get, think about a basket, okay? Because you weave a basket, okay? And so it has that ability to be termed woven, all right? But then when bone gets to the growth that we have it's termed lamellar, okay? Lamella, all right, circles. So before we go any further, we're going to look at these, okay? Now, the way I want us to do this, I want everybody to come up here with me. Because I want everybody looking down on these models. So what I've done, okay, I need y'all right here, come, okay, because I need you guys to be picturing this, because I need you to be able to understand when we're talking about this, okay. The reason you need to understand this is because this system is going to affect every other system of the body, okay? So basically what I'm trying to represent here is, let's say we've taken a cut of this one long bone, all right? And I'm laying it out here in the circle so that we're getting to look down on it like this, okay? So in the middle of a long bone is our marrow cavity. All right, that's this part right here. So imagine if I had enough pizza slices here to go around in a circle. Right down through the middle is going to be my marrow cavity. Okay, so you'll note that in the structure that they've put together right here, we have our connective tissue wrappings, okay, that are represented here in the gray, all right? Then our spongy bone, okay, do y'all remember that one? And the spongy bone is made up of the trabeculae, all right, giving it this spongy appearance. Note that it has a good blood supply, all right, because that's my bone marrow, all right. So now, working outward, this section like this, okay, and remember, it's going to run the length of that bone. Okay, is everybody picturing this with me? So now, this outer portion of bone, known as my compact bone, this is my osteon, which we mentioned, and the osteon is made up of these lamella, okay, meaning that lamellar turn, all right? So we have all these circles, concentric circles, okay? One of the things I tried to point out on Monday, if you look at this one right here, they're trying to represent the collagen, and the collagen is in one direction on one lamella, the other direction on the other lamella next to it, because we've given it strength. Because that hydroxyapatite is actually laying down around these collagens, okay? In the middle that they're trying to represent, okay, in the middle of this osteon, where they're trying to show us there's a blood vessel, this is a Haversian canal, because what's getting represented, I have a blood supply right in the middle of this canal. So for every osteon that you see with these concentric circles, okay, these lamella, all right, I've got a blood supply. If I have a blood supply, I have access to all my cells, okay? Now, in looking at these, the other part that I tried to point out, we mentioned that our osteocytes this time, okay, the osteocytes, what do they reside in? Lacuna. That's their home, okay? So, but this time, do you remember what those little extensions were on them? What they were called?
Dendrit?
They're dendritic-like, but they had a specific term. Started with a C. The canaliculi. I know, it's a really weird term, okay? But now, this time, look at them here, 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 here. they're trying to show you, okay, that in these lamella that have been laid down, those cells, those canaliculi, allow for, do you guys remember what type of junction?
Yeah.
A gap junction, so that it can move materials from one to the other, okay? So this osteon is the reason that it is termed lamella. However, what else do you notice about these lines? Maybe in between osteons, around it as a whole, if I had all the pizza slices? What do you notice about them? Are they present? Okay, so if I look at the osteon portion, if I look between them, they're trying to represent lines. Does everybody kind of see that? Okay, they're trying to have these lines in between the osteons. Okay, this is the way that as itty bitty baby grows to be the adult, okay, and bone has to not only grow this way, but grow this way, as these lamella, okay, these osteons break down, reform, this is the part that gets left behind and is sort of like filling in the gaps, okay, so that we create this hardened outer portion, okay? Does that make sense? Now, what do you notice about this? And like I said, if I had all the pieces of the pizza slices, it would be going all the way around along the diaphysis of that bone, the shaft. What are these trying to show me?
Is it the same, like, connective structure as the osteon? It's like sort of this way.
We've got our collagen parallel for strength.
Is it trying to like be like that? Basically, this is like a bigger version of that.
A bigger version and closing it.
Yeah.
Okay, so these are really, really concentric. These, I said concentric because they go around. Okay, in these, they are really, really concentric because they go all the way around the bone, enclosing these. Then, let me see here. I've got my, where they're trying to show that if this is a canal, this is a canal. They're trying to show that blood vessel running in this vertical fashion. But what other direction do you see the vessel running? Horizontal. Okay, so we have blood supply not only running vertically down these Haversian canals, we see our blood supply penetrating all the way across, okay? Telling me, once again, bone is so dynamic. The other part that we're going to be closing up, okay, closing around, once again, what do you think this is representing? I mentioned it here in the gray.
Connective tissue.
Connective tissue wrapping. Okay? It's got little fibers that are penetrating into the bone to hold it there. Okay? And then it's going to be the source of my stem cells, the ones that are those osteochondral progenitor cells. So if this part of the bone broke, I would have in this wrapping right here my cartilage cells to give rise to the hyaline, and then I have access to